Hi, welcome to Algebra 2, 2-4 complex number operations, example 6. Solve a quadratic equation with complex solutions. How can you solve x squared plus 4 equals 0 using factoring? So we're going to put everything we learned together and solve our last example. We know how to factor quadratics, right? However, x squared plus 4 will not factor out with real numbers because this is the simplest form in real numbers. So now that we learned how to factor using complex numbers, we're going to use that skill to write it as a difference of squares. Remember, I is equal to square root of -1, which doesn't exist in real life. This is an impossible number in real life, but we defined it as a complex number index I. Okay, so I square is equal to -1. Okay, so in order to rewrite this as difference of squares, we want a squared minus b squared, right? But of course here we have a squared plus b squared, which doesn't make sense, but we can make it as -4 as long as we multiply by -1. So we can rewrite this as x squared plus or minus -4, which is the same as adding 4, but we're going to rewrite that -4 as 2i squared because I squared is equal to -1, and 4 square root 4 is 2. So we're going to have 2i squared instead. So then that's equal to 0. You'll be able to factor out by using the difference of squares and be able to solve for x, which is plus or minus 2i. So let's try number 6. Find the values of x that will solve each equation. Part A, x squared plus 49 equals 0. Part B, 9x squared plus 25 is equal to 0. See if you can solve it by yourself. Pause the video and come back when you're ready for answers. Okay, are you ready? All right, so first step, rewrite as a difference of squares. So x squared plus 49, you can rewrite it using complex numbers, right? So -7i squared is equal to 0 would be your next step. And then you can factor out using that complex number. So x plus 7i and x minus 7i would be your factors. And solving them, you'll be able to solve for x, which is -7i and positive 7i. So x is plus or minus 7i. And b, using the same method, rewrite this as a difference of square, but you need to factor out your 9 as well. So there is a 9, but 3x squared would be 9x squared, right? So rewrite it as a squared minus b squared, right? So that includes your first term as well. If it's not just x squared, you have a coefficient in front of your first term, then you also need to see if that could be rewritten as a squared. And then that would be -5i squared. That would be your second term is equal to 0. And so your factors would be 3x plus 5i, and then times 3x minus 5i is equal to 0. So if you solve for x, you will be able to find that x is equal to -5/3i and positive 5/3i. Okay, so that was your last example. We're going to summarize our lesson. So in lesson 4, we looked at complex numbers and operations. Remember that the imaginary unit I is equal to -1, a square root of -1, which is impossible in real life. That is why it's called imaginary unit. It doesn't happen in real life, but we can imagine. If that's true, we have a complex number system. So complex numbers are written in the form a plus bi, where a and b are real numbers, but I would be the imaginary unit. So we still have to use real numbers in our complex number system, but as long as you have the imaginary unit, it altogether is a complex number, okay? So the 4 basic operations can be applied to complex numbers such as 2 plus 3i, 5 minus I, multiplication, division. And we also looked at factoring our quadratics using complex number system. So adding, you can add the like term. Subtracting, you can add the real numbers and the imaginary unit as you can treat them as variables. But remember, they could be turned into real numbers once you have I squared. Then it's equal to -1 in real number. So complex numbers are not always going to stay in complex number. If we, in the process of solving them, we'll be able to change them back to real numbers. So sometimes we need to be able to imagine using complex numbers so that we'll be able to solve more problems in real life. We cannot be stuck in square root -1. We can even use that as an imaginary unit I, and we'll be able to solve a lot more problems in real life. And that's the magic of having complex numbers. All right, so that was lesson 2-4, complex numbers and operations. We'll continue with the next lesson in the next video. Bye.